Scientists. Welcome to 4.2, Newton's second law. So this document should be in Notability. If you don't have it in Notability, go ahead and pause the video and put this into Notability so you can write on it and then split your screen between this video and your notes. All right, so we're going to read a little bit about Newton's second law. Okay, so this says mass and Newton's second law. Any change in an object's velocity, let's think about that word, velocity. Okay, velocity is the same thing as speed. Okay, so it's another science word for speed. So any change in an object's velocity or speed is called acceleration. Acceleration. Speeding up, slowing down, and changing direction are all acceleration. Anytime a change happens in an object's speed. Right. Newton's second law of motion has two parts. One part explains how acceleration is related or connected to the mass of an object. It says that the same force will accelerate a small mass more than a large mass. So if, let's say, you push with the same force, if you push a small object, okay, it will accelerate the small object more than the large object. So here's a definition of acceleration. Acceleration is how fast an object changes its velocity. Okay, so we have a picture here, someone pushing a shopping cart. This says it is easy to change the acceleration of an empty grocery cart. A grocery cart with nothing in it. It's easy to change the acceleration. Okay. So our first question over here that you'll write in is acceleration. What is it? What is acceleration? So you're going to add a text box here. Okay, and we can write the definition of acceleration. We can find that right here on this page. So acceleration is how fast an object changes its velocity. So that could be a change that makes it go faster, could be a change that makes it go slower, or it could be a change that changes its direction. Okay, and number two, what does Newton's second law say about how acceleration and mass are related? Okay, so let's look at our reading. How are acceleration and mass related? So here it says, one part explains how acceleration is related or connected to the mass of an object. So Newton's second law says that the same force will accelerate a small mass more than a large mass. Okay. Newton's second law says that the same force will accelerate a small mass more than a large mass. Okay. Let's keep reading. So we had an empty grocery cart before. Now our picture has changed. Imagine that you have to push an empty grocery cart. An empty cart doesn't have a lot of mass, so it's easy to push. You don't need a lot of force. However, after you fill the cart, it has more mass. The same force you use to push the empty cart does not accelerate the larger mass of the full cart as much. You have to push with more force with a larger mass. So you have to use more force to make it move. You also have to use more force to make it stop. It is more difficult to change the acceleration of a full grocery cart. This one's now full of things. It has more mass. Okay, question number 3. Why is it easy to push an empty grocery cart? Okay, it's easy to push an empty grocery cart because it doesn't have a lot of mass. It doesn't have a lot of mass. It is easy to push an empty grocery cart because it doesn't have a lot of mass. Right. Number 4, does a filled grocery cart have more or less mass than an empty cart? A filled grocery cart, does it have more or less mass? Think about that. Write your answer. Hopefully you said a filled grocery cart has more mass than an empty cart. All right, number 5. Do you need more or less force to push a full cart compared to an empty cart? You need more or less force to push a full cart compared to an empty cart. All right, hopefully you've thought of or written down your answer. So hopefully you said you need more force to push a full cart compared to an empty cart. All right, number 6. Why do you need more force to accelerate the full cart than the empty cart? Why do you need more force? Okay. Why do you need more force? You need more force to accelerate the full cart because the full cart has more mass. Right? And when things have more mass, Newton's second law says that we need more force to change their acceleration. So a few vocabulary words before we read. Related to means the same thing as connected to. Okay, depends on is connected to. Is connected to. All right. Another part of Newton's second law explains how acceleration is related to the force acting on an object. It says that a greater force will cause greater acceleration. When 2 people push the grocery cart, the force is greater. The greater force makes the grocery cart accelerate more rapidly, which means more quickly. Okay, here we have 2 people pushing that full grocery cart. Okay, a greater force can make the grocery cart stop, start, or change direction more easily. So here we have a key idea. Newton's second law of motion explains how acceleration, force, and mass are related. It says an object's acceleration depends on the mass of the object and the size of the force acting on it, or the strength of the force acting on it. Okay, let's see our last few questions. Number 7, what does Newton's second law say about how acceleration and force are related? What does Newton's second law say about how acceleration and force are related? Okay, so let's look at our reading here. It says that a greater force will cause greater acceleration. Okay, a greater force. Newton's second law says a greater force will cause greater acceleration. All right, and 8 is about the key idea. How are acceleration, mass, and force related? Okay, so this is in our key idea box, right? So Newton's second law says that an object's acceleration depends on, or is related to, the mass of the object and the size of the force acting on it. Okay, that's over here in our key idea. Right, so the more mass an object has, right, the more force you're going to need to accelerate it. Okay, if the mass stays the same, let's say we have 2 people on this grocery cart pushing it, okay? Let's say that the grocery cart stays the same things are in the grocery cart, and the force decreases. So let's say this person in the red shirt stops pushing the cart or leaves. Okay, so then it's just one person pushing the cart. Will the object, so will the grocery cart, accelerate more or less? So if our force decreases, our acceleration is going to accelerate, it's going to accelerate less. So we can say if the mass stays the same and the force decreases, the object will accelerate less. All right, make sure you get this turned into Schoology. You should have all the questions answered here. Should all be filled in.